Bismillah Rahman Rahim. Hello everyone. Welcome back to the PL-300 exam preparation series where we are going to have a look at the practice questions. Since the last video on the practice questions, these are the topics that we have covered. So we have completed the data modeling, and as part of the data modeling, the first topic that we did was choose between direct query, import and dual mode. So this is something that you do it inside the Power Query editor, but it is obviously directly related to the data modeling as well. Then there are a few topics like improve performance by choosing optimal data types, improve performance by identifying and removing unnecessary rows and columns, improve performance by summarizing data. So these are the three topics that are directly related to optimizing the data model. And then we enter into the DAX development, so DAX programming. So the topics that deal with the DAX programming include identify implicit measures and replace with explicit measures, create single aggregation measures, use basic statistical functions, and use calculate to manipulate the filter. So these are the four topics that are directly related to DAX programming. So now let's have a look at the practice questions that pertain to these topics that I have just shown. So now let's start the practice question. So let's start with question number 1. So the question number 1 states that you have a Power Query named sales that imports the columns shown in the following table. So you have a table where you have the name, description, and the sample value, and the name of this Power Query is sales. So the statement says users only use the date part of the sales data field. Only rows with the status of finished are used in analysis. You need to reduce the load times of the query without affecting the analysis. Which two actions achieve this goal? So based on the statement that I have just read, I have to pick two actions out of these 5 actions, and the actions are remove the rows in which sales status has a value of cancelled, remove sales data, change the data type of sales delivery time to integer, split sale data into separate date and time columns, and remove sales cancel date. So let's look at the answer to this question, and the answer is option number A, which says remove the rows in which sales status column has a value of cancelled, and the other correct answer is split sale data column into separate date and time columns. So what actually we wanted to know, or what was the objective, was we wanted to reduce the load times of the query without affecting the analysis, and the analysis had this condition that we only want to use the date part, and we only want to use the status which has the finished in the sample value. So the first bit is that we do not require the cancelled bit, so we can easily remove the column in which the rows have a value of cancelled. And the other bit obviously is that we can remove the cancelled date because again we do not want to use this in the analysis. So these are the two bits that pertain to reducing the load times, although there could be any other improvements, but because the question was just related to the statement that is there in the first part, so these were the two actions that actually solved the problem. Question 6. You have a Power BI model that contains a table named sales. The sales table contains the following columns: order line ID, product ID, unit price, order ID, and quantity. So these are the 6 columns that we have in the sales table. Orders are uniquely identified by using the order ID and can have multiple order lines. Each order line within an order contains a different product ID. You need to write a DAX measure that counts the number of orders. Which formula should you use? And the 4 options given to us are count sales order ID, count A sales order ID, count rows sales, and distinct count sales order ID. So let's look at the correct answer. So the correct answer is option D, which says distinct count sales order ID. And why we have chosen distinct count? Because of this statement. So here the statement says that the orders are uniquely identified by using the order ID and can have multiple order lines. So within each order we have in the order line we have a different product ID, but the question says that we want to count the number of orders. So this can only be done by the distinct count, because here now it is going to look at the distinct order IDs, because we actually want to count the number of orders. If we want to use count or count A or count rows, these are going to give you the count of all the transactions or all the rows in the particular table. So it is not going to give you the number of orders. So that is why distinct count with sales order ID column is going to give you the correct answer. So this is why we have chosen option D, which is the correct answer. Question 9. You are creating an analytics report that will consume data from the tables shown in the following table. So we have these two tables, sales and employee, and then there is the columns which are available in the two tables and the associated data type. There is a relationship between the tables. There are no reporting requirements on employee ID and employee photo. You need to optimize the data model. What should you configure for employee ID and employee photo? So we have two areas. One pertains to the employee ID and one pertains to the employee photo, and we have the same options, four options, which are change type, delete, hide, and sort. So we actually have to select one of the options from both of these answer areas. So let's look at the correct answer. So the correct answer is that for the employee ID we can hide, and for the employee photo we can delete. So we have seen in the question that there is a relationship, and we can see that the employee ID is the column that is actually the common column. So the only relationship can be built on the employee ID, and we have seen that because these are the ID columns, so they have nothing to do with the analysis, but we cannot delete this column. So what we can do is that we can actually go and we can hide this column. Similarly, it is already integer, so there is no need to change the data type, and obviously sorting has nothing to do with any of this. So the first option is that we can hide the employee ID. Similarly, the reporting requirement says that employee photo is also not required for the reporting requirements, and we can see that the employee photo is part of the employee table. So we can simply go and we can delete the employee photo because we do not require it for any of the analysis. So that is why hide and delete are the correct answers to this particular question. Question 11. You have the tables shown in the following table. So here in this diagram, we have the three tables. Table names are campaigns, ads, and impressions, and these are the columns for each of the tables. The impressions table contains approximately 30 million records per month. You need to create an ad analytics system to meet the following requirements. Present ad impression counts for the day, campaign, and site name. The analytics for the last year are required. Minimize the data model size. Which two actions should you perform? So we have these four actions, and we have to select the two actions that we need to perform in order to meet these requirements. So the choices are: create one-to-many relationship between the tables, group the impressions query in Power Query by ad ID, site name, and impression date, aggregate by using the count rows function, create a calculated table that contains ad ID, site name, and impression date, create a calculated measure that aggregates by using the count rows function. So let's have a look at the correct options. So the two correct actions are: create one-to-many relationships between the tables and group the impressions query in Power Query by ad ID, site name, and impression date, and aggregate by using the count rows function. So if I have a look at these three tables, so basically the campaigns and ads, these have the common column campaign ID. So for every campaign, there could be multiple ads. So this is a one-to-many relationship, but the important point to understand here is that this is a one-to-many relationship between two dimensions. And then this is the impressions table, which is the fact table, and the relationship between the ads and impressions is the same as we have between the campaigns and ads. So here we have the ad ID as a foreign key. So this is the fact table. So now the requirement is that we have to actually perform ad analytics based on these requirements. So we have to present ad impression counts for the day, campaign, and site name. So we understand that this is a very large table, which is 30 million records per month. So the fact table is generally a large table, but we can improve the performance of the data model and minimize the data model size by grouping the impressions query. So we can perform a group by here by using the ad ID, site name, and impression date as part of the group by, and then we will have another column which will have the count for these three columns. So once we group these, then we will be able to know the impression counts for the day, for the campaign, and the site name. So this is what this action here is actually representing, and we will also be preserving the date. So we can basically, once we have the date, then we can also perform the last year analytics as well. So we do not require the impression time, so that is why the impression time is not included here. And obviously impression ID is something that is just a part of the just an ID for this particular column. So we do not require a primary key for the fact table. So this is the function, or this is the action that actually will reduce the size of the table and also preserve everything that is required for this analytics. And then obviously the first part we have already explained, that for these three tables where we have a dimension and a subdimension and a fact table, we will have a one-to-many relationship, so that we can actually filter through from the campaigns to the impressions. We do not need to create a calculated table because there is no requirement to create a calculated table. We can just compress this table and by using the group by we can do that. And similarly, we do not need to create a calculated measure because this part can be done inside of the Power Query editor, and we can simply reduce the size of the data model inside the Power Query. So once these three tables are loaded as a data model, we have less number of rows for the impressions table. So this is the answer explanation for question number 11. Question 12. You import a Power BI dataset that contains the following tables: date, product, and product inventory. So these are the three tables that are part of the Power BI dataset. The product inventory table contains 25 million rows. A sample of the data is shown. So for the product inventory, this is a snapshot of, or the sample of the data. The product inventory table relates to the date table by using the date key column. The product inventory tables relates to the product table by using the product key column. You need to reduce the size of the data model without losing information. What should you do? So we have these four actions, and we have to actually pick the option based on the statement that has been explained here. So the options are: change summarization for date key to don't summarize, remove the relationship between date and product inventory, change the data type of unit cost to integer, remove movement date. So let's look at the correct answer for this question, and the correct answer for this question is option D, remove movement date. So if I come here to the question, so the thing that we are actually trying to solve is that we need to reduce the size of the data model without losing any information. So we do not want to lose any information, which means that we cannot delete any of the columns unless that column is redundant. So if we come here, we can see that this column, date key and movement date, so both of these columns are actually representing the same information, because if you have a look at this, so this is just the integer form for the date, which is 28 December 2010. Similarly for here, you can see 29 December 2010, and so on and so forth. And we can see that the rest of the columns we actually cannot do anything because they represent information which can be used in the analysis. So if we come and look at the options here, so here the most appropriate option is that if we can simply go and remove the movement date, because this is a redundant column, then we can actually reduce the size of the data model and we do not even lose any information. So that is why we have picked the remove movement date as the answer to this particular question. 15. You have a data model that contains many complex DAX expressions. The expressions contain frequent references to the related and related table functions. You need to recommend a solution to minimize the use of the related and related table functions. What should you recommend? So we have four options: merge table by using Power Query, hide unused columns in the model, split the columns into multiple models, and the transpose. So let's have a look at the correct answer. So the correct answer is merge tables by using the Power Query. So remember, we discussed this in one of the videos that related and related table actually are based on the relationship between the table. So you need to have a one-to-many relationship between the table. So if you are having issues with the complex DAX expressions that are based on related and related table, so you can get rid of the related and related table by reducing the relationship. So if we merge the tables inside the Power Query, then we actually cannot use the related and related table functions. So based on the problem that has been specified here, which is actually related to the related and related table and the complexity because of these two functions, this is the most appropriate answer, that you can just go and merge the tables inside the Power Query. Hiding the tables or splitting the model into multiple models and transpose, these are actually not going to solve any of the problems related to the related table and the related function. So that is why merging tables in the Power Query is the correct answer. Question 16. You have a Power BI model that contains two tables, sales and data. Sales contains four columns named total cost, due date, ship date, and order date. Date contains one column named date. The tables have the following relationship: sales due date and date, sales ship date and date, and sales order date and date. So basically we have due date column, ship date column, and order date column in the sales table, and all of these have relationship with the date column. The active relationship is on the sales due date. So the active relationship is on this particular on these particular columns, due date and date. You need to create measures to count the number of orders by ship date and the orders by the order date. You must meet the goal without duplicating data or loading additional data. So the proposed solution is that you create the measures that use calculate, count, and use relationship DAX functions. Does this meet the goal? And the options are yes or no. So let's have a look at this particular question's answer. So the answer is that yes, the goal can be met. So here, if you have a look, it says that we have one active relationship. So the relationships between ship date and order date and date are going to be inactive. And we want to actually use these inactive relationships to answer this particular question, which is that we need to count the number of orders by the ship date and by the order date. And we have a complete video on this, that we can convert the inactive relationships inside a DAX function. So we can create a count of the whatever number of orders that we want to do, and we can make the inactive relationship by using the use relationship function inside the calculate statement. We have already seen this, so this is the right answer. So if you propose this solution, it is going to meet this goal, and this is the answer to this question. Question 17. You have an Azure SQL database that contains sales transaction. The database is updated frequently. You need to generate reports from the data to detect fraudulent transactions. The data must be visible within 5 minutes of an update. How should you configure the data connection? The options that are given are: add an SQL statement, set the command timeout in minutes setting, set data connectivity mode to import, and the last option is set data connectivity mode to direct query. So let's have a look at the correct answer. So the correct answer for this question is set data connectivity mode to direct query. So if we have a look at this particular question, the most important thing to consider here is that the data must be visible within 5 minutes of an update. So this requirement can only be met if we have a refresh rate which is 5 minutes, and this 5-minute refresh rate can only be achieved if we have a direct query question, which direct query connection, which actually updates the data in real time. If we go for the import mode, then this obviously cannot be done, and these two statements have nothing to do with the configuration of the data connection. So that is why option D, which is the setting the data connectivity mode to direct query, is the correct answer. Question 18. Your organization's data warehouse updates its sales data every 15 minutes. The Power BI report dashboard built for the sales team needs to reflect near real-time data and should also be optimized for fast report rendering. What mode would best suit this particular scenario? And the options given are import mode with a scheduled refresh every 15 minutes, direct query mode, dual mode with more frequent queries set to direct query, import mode with incremental refresh. So let's look at the correct answer, and the correct answer is the direct query mode. And that the reason for using the direct query is that it allows the dashboard to reflect near real-time data without the need for scheduled refreshes, ensuring that the data is as current as the source. So in the question, we have the requirement that we have to reflect near real-time data, and also the data refreshes every 15 minutes. So if we choose the import mode, we obviously cannot refresh less than 30 minutes. So the minimum time that can be set for the refresh in import mode is not 15 minutes, it's 30 minutes. So the correct answer to this question is option B, which is direct query mode. Question 19. You are working with a large dataset containing 5 years of daily sales data. The majority of your report visuals use monthly sales figures. Which step will most effectively optimize the performance of your report? And the options are: convert the data to direct query mode to pull only needed records, create a monthly sales aggregation table in Power BI, rely on Power BI's built-in data compression and use the daily sales data for all the visuals. Use slices to restrict visuals to shorter time periods. So let's have a look at the correct answer. And the correct answer here is to create a monthly sales aggregation table in Power BI. And the explanation here says that by aggregating the data at the monthly level, which aligns with the primary visual requirement, you can drastically reduce the number of data points that Power BI needs to process for the visuals, thereby optimizing the performance. So here, because we have 5 years of data and it is a large data set, but the reporting requirement or the granularity for the reporting is based on the monthly level. So if we reduce the data from daily to monthly level, there will be a drastic reduction in the data size. The number of records will obviously shrink, and this is going to optimize the performance of the report. So that is why creating monthly sales aggregation, which is option B, is the right answer. Question 20. You notice that a numeric column item code which doesn't involve any arithmetic operations in your reports is set as a decimal data type. How can you optimize this for better performance in your data model? And the 4 options given are: convert the column to the text data type, convert the column to whole number if no decimal points are present, leave the column as decimal type since it's already a numeric data type, convert the column to a Boolean type. So let's have a look at the correct answer. So the correct answer is that convert the column to whole number if no decimal points are present. And the reason for this is that whole number data type is more storage efficient than decimal. If item code doesn't have any decimal points and no arithmetic operations are performed on it, converting it to the whole number will improve the performance. So we have already covered the importance of choosing the right data type in one of the videos. And here again, we are going to use the same knowledge that we saw in that video, that we should convert this column to a whole number if there is no decimal point present in the data. So this is going to obviously optimize the data model, and we will have a better performance. So that is all for this particular video. So we had a detailed look at the questions and their answers, and had a look at some of the explanation related to each of the answers. So once you finish this video, then please do solve the practice questions. There are practice questions related to this topic, and the answers for those practice questions are also given. So that's all for this video, and I'll catch up with you in the next one.